All right, you are welcome to Vital tutorial. Uh, my sincere apology. Uh, in today's class, this should be the first video you're supposed to have uploaded before chain rule, product, and rule. And I sincerely want to appreciate those who have corrected me with the spelling of differentiation. I was actually using C instead of T. I'm grateful for that. Today we'll be looking at the general differentiation, basics of differentiation. Then other we consider the general method of the form s to the power of n and ax to the power of what? N. Now, let's go. Now, when we say y, if y equals to s to the power of n, and if y is equals to a to the power of n, we will come to this. Let's face this. Now, the derivative, if you differentiate, if you find the derivative of this, if you find the y ds of this, I've already proved this for us. We are going to have the y over the s will be equals to, now the first thing you are going to do is you will bring your n to the back of this. It means you use n to multiply the coefficient of s here, and the coefficient of s here is 1. N times 1 is what? N. Then s to the power of subtract 1, n minus 1. Same applicable to this. The y over the s is equals to n times a, that is a n, then s to the power of what? N minus 1. These are the things you should know. You get that? So now let's consider some examples under this first. Okay, let's consider this. Let's find the derivative of s to the power of 2, s to the power of 4, s to the power of 5, s to the power of 8. Now let's start with this. We want to find the derivative of this. We have s to the power of 2, s to the power of 4, s to the power of 5, s to the power of 8. Now, if you look at all the everything that is here, they are in this form: s to the power of what? S to the power of n. Now, but you have to note that n can be a positive or a negative number. N can be a positive or a negative number. Please note that n can be a positive or a negative. Let's consider this positive number first. Now, s to the power of 2, we can compare this with this, but you can ignore that. Let's face this one by one. Let's go with s to the power of 2. If you are to differentiate s to the power of 2, I can write it like this. Now, if you are to differentiate this means you are differentiating this in respect to what? S. Do you get that? So now if we differentiate this, now what we did here, that's what we are going to do here. So now s squared, we just say 2 times 1. 2 times 1 is 2s, then 2 minus 1, which will be equals to what? 2s. 2 minus 1 is what? 1. Then which is equals to s to the power of 1 is what? S. Anything to the power of 1 will give us the thing back. So s to the power of 1 is s, then we have 2s. I hope you get this. So these are the things you need to know. And what is here is the same thing as what? The y ds. You can rewrite this as, now you can say s squared, then the y over the s is equals to, if you differentiate s squared now, still using the same method, 2 will come to the back, subtract 1, that is 1, then n to the power of 1 will give us this. So we can see it in this manner, we can also see it in this manner. You can write it down, used to this manner. Do you get that? Excuse me. Okay, so now I hope you can do the rest yourself now. So if you are to differentiate, s to the power of 4 now, s to the power of 4, if you are to differentiate that, is going to be what? We are going to have what? We are going to have, bring the 4 to the back, 4s, subtract 1 from 4, you are going to have 3. Let's differentiate this. Bring 5 to the back, we are going to have 5s, subtract 1, we are going to have 4. Let's solve this. 8 times 8 will come to the back, we have 8s to the power of what? 7. So this is how we go about all this. Okay, so now what of if we now have a number? Now let's do this. 2s to the power of 4, 3s to the power of 5, 2 to the power of 3. Let's do this. Now, what of if we have a number? Still the same thing. N times a, right? That is what is there. N times a, subtract 1. So it means if you are differentiating this, 4 times 2, that is what? 8. Or you should focus on this s to the power of 4. Okay, let me first use this method for you. 4 times 2 is what? 8. Then s to the power, subtract 1, that is 3. Let's do this. You differentiate. Then respect to s, 5 times 3 is what? 15. Then s to the power of what? You subtract 1, that is 4. 3 times 2, that is what? 6. S to the power, subtract 1, that is 2. You get this now. So this is how we go about all this. Now I told us that this n can be a positive or a negative integer, a number like that. So now let's consider example where this n is a negative integer. Please, if you please, I want us to follow this because these are what you need. These are what you need to know. These are what you need to know before you go into chain rule, product rule, and every other quotient rule, every other rules like that. If you know all these basics, you will be very good at this course. Okay, so now let's consider some example where we are going to have, let's say we have s to the power of minus 5, s to the power of minus 3, and let's say we have minus 2, s to the power of minus 1 over 3, minus 3, s to the power of minus 2 over 3, and let's say we have 2 to the power of half, like this. Okay, now if we want to differentiate all this, we want to find the y over the what? The s. So the same thing we still do. Minus 5 will come to the back. I'm going to have minus 5 s to the power of, then you subtract 1, which will be what? Minus 5 minus what? 1. So our answer will be what? Minus 5 s to the power of minus 5 minus 1 is what? Minus 6. So this will be our answer. Solve this also. If you solve this, we are going to have minus 3 will come to the back, minus 3, then s to the power of minus 3 minus 1. So we are going to have minus 3. Minus 3 minus 1 is nothing but what? Minus 4. How to get this? Let's solve this. Minus 1 over 3 times minus 2. Minus 1 over 3 times minus 2. This is it. You can do it like this. Minus 2 into, now we focus on this s first. We focus on this. So minus 1 over 2 will come down. It's going to be minus 1 over 3s. Then we are going to have minus 1 over 3 minus 1. Do you get that? Now minus 1 over 3 minus 1. Now this one that is here is the same thing as, what is here is 3, is the same thing as 3 over 3. Do you get that? Or if you don't get this, minus 1 over 3 minus 1 all over 1. The LCM of 3 and 1 is 3. 3 in 3 is what? 1. 1 times minus 1 is minus 1. Minus 1 in 3 is 3. 3 times 1 is what? 3. So minus 1 minus 3 is what? Minus 4 over 3. So now it means minus 2 into, okay, let me see this. Minus 2 times minus 1. Minus we cancel out minus, then we have 2 over 3 s to the power of what? S to the power of minus 4 over 3. So this will be our answer for this. Do you get this? Okay, so now let's solve this. The next one here is minus 3 s to the power of minus 2 over 3. Now the same method, focus on this s, or if you want to solve it direct, minus 2 over 3 times, this one is coming to the back, and when it comes, it's coming to multiply this. So minus 3 times minus 2 over 3, that is what is there. You get that? And minus 3 times minus 2 is what? 6 over 3. 6 over 3 is what? 2. So that is, let me solve it in a way we understand. So let's focus on this. Minus 2 over 3 s, then you subtract 1, abi? Minus 2 over 3 minus 1. How do you get this? So now it means that if we multiply this with this, we are going to get minus 3 times minus 2, that is 6 over 3 s to the power of minus 2 over 3 minus 1 over 1. Our LCM here is 3. 3 in 3, 1 times 2 is 2, minus 1 in 3 is 3. 3 times 1 is 3. So 2 minus 3 is what? Minus 1 over 3. So that is minus 1 over 3. 6 divided by 3 is what? 2s to the power of minus 1 over 3. So that is our answer. Do you get that? I hope you understand this. So this is how to differentiate all this. So the last but not the least that is there is 2s to the power of half. 2s to the power of what? Half. Right? So now let's differentiate. 2, open your bracket, half will come to the back of the s. Then you subtract 1, that is half minus 1. So now 2 times half, that is 2 times 1, that is 2 over 2s. Half minus 1 is still what? Half. So now 2 over 2 is 1. 1 times s to the power of 2 is s to the power of half is still this. So this is our answer. I hope you understand all this. Okay. So these are the way we differentiate. So now, what of if we now have s? You want to differentiate s alone. How do we differentiate this? Now, still the same method. You have to know that this s is raised to the power of 1. Anything standing alone is raised to the power of what? 1. So it means that if you want to differentiate this, 1 times 1 is still what? 1, right? So it's going to be 1 will come to the back. This is the 1. Then s to the power of that 1 is already there. You subtract 1 according to this formula. Everything we are doing it according to this formula. These two formulas you are seeing. You get that? So now, which is equals to 1s. 1 minus 1 is what? 0. And anything to the power of 0 is what? 1. So which is 1 times 1, which is what? 1. So if you differentiate s, you are going to have 1. You get this. Okay? So now, the next thing is, what of if we now have a number beside the s, either a positive number or a negative number? So let's differentiate the following. 2s minus 2s, 3s minus s, like this. Now let's differentiate this. Now let's start with this. This is 2s, right? Now you know that anything standing alone is raised to the power of what? 1, right? So now put your 2 here, then you bring the 1 to the back, then s, it's raised to the power of 1 before 1. Then you follow this formula, you subtract 1. So which is equals to 2 into 1s. 1 minus 1 is 0. 0, right? So now s to the power of 0 is what? 1. So which is 2 into 1 times 1. And 1 times 1 is equals to what? 1 times 1 is what? 1. So which is 2 into 1. So 2 times 1 is what? 2. You get this? I'm just trying to simplify this. You get this? So what this means is that anytime you are having anything like this, your answer is always the coefficient of the number. If you are the coefficient of s. Do you get that? So this is how we go about this. So now if you differentiate minus 2s, your answer is what? Minus 2. If you differentiate 3s, your answer is what? 3. If you differentiate minus s, your answer is what? Minus 1. Now let's do this now. Minus 2, if you differentiate this, you are going to have, now the s is raised to the power of 1, right? 1 times minus 2 is what? Minus 2 into, you bring the 1 now. Sorry, let's focus on this s. Now this s is raised to the power of what? 1. 1 will come to the back of the s, right? 1s. Then don't forget this is the 1. Then you subtract another 1 again. 1 minus 1 is what? 0. S to the power of 0 is what? 1. 1 times 1 is what? 1. Minus 2 times 1 is what? Minus 2. So if you have anything in this form, if you have to differentiate, the answer will always give you the number beside the s. Do you get this logic? So now what of if s now we are not talking about is in form of fraction. Now this is where you have to buy the knowledge of indices. This is where you have to buy the knowledge of indices. Now we have 1 all over s. We have 1 all over s squared. We have 3 all over s. We have okay, let's stop here. Now how do you solve all this? Now the first thing you need to know from your indices is 1 to the power of s is the same thing as s to the power of what? Minus 1. And you can see you cannot differentiate this. Now just that this one is a negative power, then you move this minus 1 to the back, you subtract 1, then you get your answer. I hope you get this now. So now 1 all over s is the same thing as what? S to the power of what? Minus 1. Do you get this? So now let's differentiate this now. If you differentiate this, you are going to have to differentiate, you are going to have this minus 1 will come to the back, to the minus 1 into, then, minus 1s into minus 1, then you subtract 1, minus 1, which is minus 1s to the power of minus 1 is what? Minus 2. Do you get that? But this minus 1 times s, 1 times this will still give us this, but the minus will remain, so minus s to the power of minus 2. You can leave your answer like this or like this. Both of them are correct. Now 1 all over s squared is still the same thing. Now in indices, this 1 all over that you are seeing is the one that is, it means minus s to the power of minus. Only that's 1 all over that you are seeing. That is the meaning. So it means that if we have 1 all over s squared, it's the same thing as this 1 all over, it will just come here at the power, so it will be s to the power of minus 2. So you see, you can also differentiate this now. If you differentiate this minus 2 to the back, you are going to have minus 2, which is s to the power of minus 2 minus 1. You get that? So which is minus 2s minus 2 minus 1 is what? Minus 3. So this is your what? Your answer. You get that? So now the next one is 3 over s. 3 over s. Now this 3 over s that you are seeing is the same thing as what? 3 times 1 all over s. You get this? So which means that 3 times, now this 1 all over s is the same thing as what? S to the power of minus 1. So 3 times this now is the same as 3s minus 1. I hope you see how we do change all these things. You get this? We are not differentiating. I'm just breaking this down so I can be able to differentiate this. Do you get that? So now minus 1 times minus 3. Now let's differentiate now. Minus 1 times minus 3 is minus 3s minus 1 minus what? 1. You get that? So which is what? minus 3s to the power of what? Minus 1 minus 1 is what? Minus 2. Do you get this? Okay, so now the next one is 1 all over what? S squared. 1 all over s squared. 1 all over s squared is the same thing as what? S to the power of what? Minus 2. Do you get this? So now let's differentiate this. Now if you differentiate the minus 2 will come down, minus 2s, then you subtract 1, that is minus 2 minus what? 1. So which is the same as minus 2 s to the power of minus 2 minus 1 is what? Minus 3. Do you get this? So now the next one here is, I think that is all. So now I hope you understand this. It's as easy as this. It's as easy as this. These are the basis that are in the general form method that you need to know. If you know all this, you don't have problem. Okay. Now, what of if we don't have something in this form? 1 all over s to the power minus 1 over 2. 1 all over s to the power of minus 3. Okay, let's start like this. Something in this form is still the same thing, the same way. This 1 all over is minus, and this minus you have to put it somewhere. So it's going to be s to the power of this minus that I'm writing first is just this 1 all over. Then don't forget this one is to the power of minus 1 all over 2. Minus times this is going to be what? It's going to be plus. So what it says is s to the power of what? 1 all over 2. Can we differentiate this now? Yes, of course. So if you want to differentiate, bring your 1 all over 2 down. 1 all over 2s, subtract 1. 1 all over 2 minus 1, which is still the same thing as what? 1 all over 2s to the power of what? Half. Because half minus 1 is what? Half. Same applicable to this. So this one too is the same as s to the power of minus. This minus is just this 1 all over. We are having minus 3. Put your minus 3 here. Minus times this, minus times minus is plus. So we are going to have s to the power of what? 3. So can we differentiate this now? Yes, of course. So it's going to be 3s to the power of subtract 1, which is 3s squared. So these are the bases you need to know. Okay. So now, what of if we now have it in the form of square root? What of if we now have square root? Let's say we have root s, and let's assume we have cube root of s squared. Okay. So what of if we have cube root of s to the power of minus 1? What of if we have cube root of s to the power of minus 1 over 2? Now look at this. Let's go with this. Now from indices, root s is the same thing as s to the power of what? 1 all over 2. Cube root of s is the same thing as what? S to the power of what? 1 over 3. Same thing. If this fourth root, same as what? 1 over 3. So now we have root s. Root s is the same as what? 1 all over what? 2. Now can we differentiate this? Yes, of course. Half times half will come down. Half s, then subtract 1. 1 all over 2 minus 1, which is the same as what? Half into s to the power what? Half. So this is our what? Our answer. Do you get this? So now the cube root of this is the same thing as what? S squared into, I told you that this cube root is then as what? 1 all over what? 3. You get that? So in indices, power with times power. 2 times 1 all over 3 is what? 2 over 3. So this is the same thing as 2 over what? 3. Can we differentiate this? Yes, of course. Bring this down. It's going to be 2 over 3s, then 2 over 3 minus 1. 2 over 3 minus 1 is nothing but what? Minus 1 over 3. So 2 over 3 s to the power of minus 1 over 3. Do you get this? So let's solve for the remaining 2 now. Let's solve for the remaining 2. So s to the power of minus 1. So this one is still the same thing as what? 1 over 3. Do you get that? Minus 1 times half is nothing but what? Minus 1 over 3. Can we differentiate it? Yes, of course. Bring minus 1 over 3, which is which is minus 1 over 3 s to the power of minus 1 over 3 minus 1. Minus 1 over 3 minus 1 is nothing but what? Minus 1 over 3 is nothing but minus 4 over 3. So this is our what? Our answer. So let's solve the last one. S to the power of minus 1 over 2. This the cube root that you are seeing is the same thing as what? 1 over 3. So 1 over 3 times minus 1 over 2 is nothing but what? Minus 1 over 6. So differentiate this, you are going to have what? Minus 1 over 6, s to the power of minus 1 over 6 minus 1. So our final answer is going to be what? Minus 1 over 6, s to the power of minus 1 over 6 minus 1. It's nothing but what? It's nothing but what? Minus 7 over 6. Do you get this? So these are the bases you need to know. Now, how do we know constants now? Now, let's assume now someone now asks you to differentiate 5. Someone asks you to differentiate 3. Someone asks you to differentiate 4. Someone asks you to differentiate pi. Someone asks you to differentiate e, like this. Someone asks you to differentiate all this. Someone asks you to differentiate e to the power of pi. Someone asks you to differentiate pi to the power of e, like this. How do we differentiate this? Now, the first question you are going to ask yourself is, now let's assume you are differentiating in respect to s. Yes, everything we are doing here is in respect to s. Now, the first thing you are going to look at is, do we have s? Do we have s attached to all this number you are seeing? Do we have anything like s here? Look at 5. It's just a number. Do you understand? 3 is just a number. 4 is just a number. Pi is not having s. You know pi is what? Pi is 22 over 7, right? E that you are seeing, this e, I think is it 1.3. I've forgotten the number, but it's a constant. It's a constant. It's just like pi. I've forgotten the number. Okay, e to the power of pi, both of them they are constant. Pi to the power of e, they are all constants in mathematics. Now, together with this number and with all this, we consider them as constant. Why? Because we do not have s attached to them. So, and the derivative of any constant is equals to what? 0. You get that? So the derivative of this is equals to what? 0. The derivative of this is equals to what? 0. The derivative of this is equals to what? 0. Do you get that? You get that? Once you have all this like this, they are all equals to what? 0. If you like it is minus 100, if you like it is minus 50, if you like it is 50, any number like this. But adding mean you have s attached to them. I've shown you this. Adding mean there's s here, adding mean there's s here, adding mean there's s here, adding mean there's s here. The derivative will not be equals to 0 and they will not be considered again as constant. Do you understand? So if you differentiate this now, what are you going to have? If you differentiate this, if we are differentiating this in respect to s, it means we are focusing on this s, right? Now look at this, pi into, let's differentiate this, pi s. Now, you know s here is raised to the power of what? 1. So we bring the 1 back, then don't forget this, what is there, then we subtract 1. 1 minus 1 is 0. S to the power of 0 is what? 1. 1 times 1 is what? 1. Pi times 1 is what? Pi. I've told you, if you are having anything attached to s, like s attached to a number, the derivative is always the what? The number. Do you understand? So if you differentiate all this now, you have 5, you have 3. But the reason why we take them as constant is because we do not have s attached to them. So that is why when you see any number, when you see that they say 0, check it. You see that s is not attached to it. Do you understand? So now let's consider some things now. Let's just consider this. Let's assume we're gonna have y equals to 3s squared, 3s cubed minus s squared plus 6. Find dy dx now. Find dy over dx to be equals to, now the major focus is on what? S cube. The major focus, that is, you bring your 3 into now. Bring your 3 down now. So it's going to be 3s, then to be 3 minus 1 minus into, now let's differentiate this. Bring your 2 down, you are going to have 2s, then 2 minus 1. Now look at this, it doesn't have s, it means it is what? 0. You get that? That is, the duration of any constant is what? 0. So now dy over the s, dy over the s will be equals to 3 times 3 is what? 9s, 3 minus 1 is 2, minus 2s, 2 minus 1 is what? 1. S to the power of 1 is still what? S. So this is our what? Answer. Do you get this now? This is how we differentiate using general formula method. Do you get that? So let's take one more example. 5 equals to s to the power of minus 2 over 3 plus s power of minus 2 plus let me use minus. Okay, let's do this. We'll take one more example. Okay. So now let's differentiate this. The y over the s will be equals to, now if you want to differentiate this power will come down, minus 2 over 3 into, don't worry about it, into, and write your s, write it back again, subtract 1, right? So now minus, you bring this one back. Now you have to put bracket here. So minus 2 will come down, minus 2s, minus 2 minus what? 1. Plus, now if you differentiate 6s now, you are going to have what? You are going to have 6. I hope you get this now. So now the y over the s will be equals to minus 2 over 3, s to the power of minus 2 over 3 minus 1 is nothing but what? Minus 5 over 3. Minus times minus is plus 2s, minus 2 minus 1 is minus 3 plus 6. So this is your what? Your answer. Do you get this? So now let's consider the last example here under this general form. The last example under general form. Okay, we have y to be equals to 1 over s root s. How are you going to do this? It's as easy as the ones we have been doing. The first thing you need to know is this one is also equals to, now you know I told you that this square root is the same thing as what? S to the power of what? 2. So this one is s, then multiplied by s to the power of what? 2. And from indices, a to the power of s multiplied by a to the power of y is the same thing as what? A to the power of what? S plus y. You understand? It means if you have the same base, different power, just pick one of the base, then add the powers together. So now if you see this one is raised to the power of what? 1. So it means 1 all over s to the power of 1 plus 1 over 2. And 1 plus 1 over 2 is nothing but what? It's nothing but 1 all over s to the power of what? 3 over 2. Can you differentiate this now? And I told you that this 1 all over is the same thing as what? Negative. So it means the what is there is s to the power of minus 3 over 2. So can I differentiate this now? Yes, of course. So it is, you bring the power to the back, minus 3 over 2, s to the power of minus 3 over 2 minus 1. If you do this, your answer is nothing but minus 3 over 2, s to the power of what? Minus 3 over 2 minus 1 is nothing but what? It's nothing but minus 5 over 2. So that is our answer. So here ends the class on the basis of differentiation. Based on differentiation, that general method of the form s to the power of n, a s to the power of what? N. Thanks. Please help us share this video to your friends who might be in need of this. Thanks.